challenges and solutions. Thank you very much. Good morning. Can you hear me well? Can we start? Ah, I'd like to thank you for your time. I'm go to listening to Owens Corning about the composite rebars. First of all, I'm going to talk about about Owens Corning. Everybody knows we are a company. We have 25,000 employees. We are at 69 years at Fortune 500 and in 31 countries all over the world. We have worked in several segments, and we are innovating in composites since 1938. And we invented fiberglass. We have our distribution, what we do all over the world in terms of composites. We have our operations in the city of Rio Claro. We have 2 plants in Rio Claro. We are working in Brazil since 1972. And we have the operations all over the world. And I'd like to call attention to our research centers. We have 3 research centers, one in north of the U.S., one in the south of France, and one in China, always innovating and searching for innovations in composites. Here to show you where we are. Since 1972, we have a technical lab whose purpose is to reproduce the processes of our customers. And once we reproduce them, we can test some of the mechanical properties that composites generate. In Brazil, we produce these materials in pink, and we import the ones that are not produced in Brazil for several applications. Let's talk about the rebar. Before we talk about rebar, I like to show you this slide. This chart is scary but clarifying because it shows the evolution of the number of CO2, quantity of CO2 in our atmosphere. And if you're older and you thought there was something, the scientists were delusional, that's not true, because the chart is until 2020. From 2020 onwards, it's a forecast. Even if the generation of CO2 decreased markedly, in 2050, I hope to be alive to see, we would have an increase of 1.5 degrees in the average temperature of the Earth. And where does part of that come from? Civil construction, basically from steel. For you to produce steel, we generate a lot of CO2, so we need to have a lesson and seek a better environment for all of us in the planet. And where is the solution? One of the solutions to replace steel is composite rebar. Is it something new? No. The MIT studied that back in 1951. Since then, it's ready. In 1951, it was there. We haven't used it yet. And what are the advantages? In addition to the environment, it's stronger. The resistance to rupture of the rebar, it's much better in composite rather than steel. The lightness, it's stainless. There is no oxidation. There is no structural issues. and it's been approved by standards all over the world. And when we talk about approved by standards, we have to think about the several applications that the rebars have. So we start from the structural in black, and we'll have non-structural applications. When we look at the structural applications, we have to be concerned about safety. It's a safety item. It's not about anything. It can create serious issues in people's lives. So if you have a problem of safety, it needs to be standardized. We cannot build up just like that using composite rebars just like that, as if it had the same characteristics of a steel rebar. It's very important for us to evolve with that application.
There are other applications that are less demanding mechanically speaking, but they also require standards. For example, cracks may open or a channel that may leak, and so on and so forth. I like this chart when I think of the differences between a composite rebar and a stainless steel one. Civil engineers are very used to working with drainage. And when we look at the behavior of steel, when we tension it, steel deforms up to 10%. So when we're building a construction and there's a crack in the wall, a very fine one, less than 10%, we're okay with that because it'll take a long time before it breaks or ruptures. Steel is elastic and also plastic, but a composite rebar is very different. It is only elastic. In other words, it doesn't deform, or if it does, only very slightly. When we look at, for example, a composite rebar structure, 1.5%, 1%, and steel goes up to 10. When we look at the breaking strain for a composite rebar, it's something like 1,000 megapascal. Steel is around 600. So for situations in building where a rebar is under tension, well, then this is an excellent application for it. But always remember that there's the issue of the deformation. So how should we work with this? And how do we support the market and enable it to overcome the challenges of deformation in Brazil? So the standards are very necessary. In Brazil, there are two standards. The first one is the standard about the material itself, the rebar material. The second standard is about planning or projects, how the planners or the engineers will calculate a structure and how the structure has to behave. In other words, how can they put their heads on their pillow at night? So these are scientific aspects that they need to follow in order to implement rebars. And these two standards are at the public, or just about at the public consultation stage. The civil engineering standard is ready and has been waiting for the second material standard. We have been working on it for 2 years with a great deal of technical discussion, a lot of experimentation, Whenever we came face to face with an impasse, we would carry out experiments and measurements. The standard was drafted by a set of companies and universities, and the focus was technical, and the purpose was to raise this application to its proper level, in other words, a safety application. So how was this work carried out over these 2 years? So that we were able to arrive at the final version, which should be in public consultation by September 15th. It is expected to come out by September 15, and then there's 2 months of public consultation for the standard to come back from that consultation, and then it is drafted and edited, and by the end of the year it will be ready and in force. So what was the basis that we used? We have to go back to materials science. We need to have a material with properties, performance, and cost. We need to look at 3 things at the base of the triangle. The structure itself. What are the characteristics, or what are the materials that we will use to make this rebar structure? We've been working on the standard. The discussion took a number of months, and at the end we decided to use ester vinyl or vinyl esters and epoxy materials. We carried out experiments and looking at chemical strength or resistance, and we defined the structure. And then the composition and who are the suppliers of materials. For example, does the fiber supplier provide a guarantee? And how will it be processed? We're talking about a continuous process, a chemical process, pultrusion. And in the pultrusion mold, there's a chemical reaction going on, and we need to convert raw material into product. It needs to happen correctly so that the end properties are met. So I like to show a kind of a prism shape here. It helps us understand the science behind this type of composite material and what will be assessed. So at the top left, I'm not going to touch on all of them, but let's look at let's see what material will be evaluated for us to have our application. So the glass transition temperature and degree of cure. So we've chosen the resin, and then there's a glass transition or vitreous transition temperature. We process it. Has it been cured correctly? If the degree of cure is right, if the conversion of raw material into product has happened correctly, then we will have a vitreous transition temperature which is needed for use in the building industry. In other words, it cannot soften. The TG, the temperature at which polymers and the molecules begin to move, if they're moving, then it has weakened. That's one of the foundations for using these magnitudes in the standard. Water absorption and resistance to alkalines, chemical resistance. What do we have to ensure? What do we have to avoid? We have to make sure that there is no water absorption and that there is alkaline resistance. It is a very base. So at the moment of application, and water, for example, is the same thing. It's a very small molecule. Any kind of crack or fissure, water will get into the reinforced concrete, and then delamination will occur. In other words, the rebar structure will lose its structure, and if the beam is delaminated, the property, the mechanical property that the civil engineer had signed off on is no longer there. It's very important. The fiber content, this is extremely important, let me argue on behalf of that, because the fiber is the material that is going to provide the mechanical properties. The more fiber, the greater the mechanical properties. And then build issues. Engineers need to know the area of the cross-section to understand the rupture force. In other words, the force and the modulus. And finally, the elasticity modulus and adherence. The pull-out test. It needs to be adhering in the cement modulus, and it should not move. So we're ready for this at Lewis Corning. We've carried out the measurements, and in terms of the standard, there are two conditions which I think are extremely important. There are a whole range of properties which are provided for in order to qualify. In other words, the rebar manufacturer has to demonstrate that they have complied with all of these requirements in order then to be qualified or permitted to produce. You're qualified, you can produce, because you have attained all of these figures or performance figures. After qualification, they will then begin to produce. As I said, it's a continuous process. Like any process, it's subject to variations. The standard says that it's mandatory that there should be an analysis certificate or report per lot, per batch. There's a lot of discussion about what is a lot, what is the size of a lot, but with fewer analyses that ensure that overproduction, the rebar will meet the requirements listed above. Another thing is there needs to be traceability and accountability for the rebar manufacturers. So there has to be identification on the material. So you have the test reports and the certificate and the traceability, and they're thus married together. In the case of necessity, there's a way of tracing this, and it has to be traceable all the way back to the raw material that the manufacturer used. So they have accountability and responsibility. How is Owens Corning preparing? There are challenges. The standardization itself is a challenge. How do you meet an ABNT, Brazilian standard? Our colleagues earlier at Procure we're talking about self-construction. We know how that works. People who are building a house, for example, they're building a house on the corner in a small town, and they have a supplier. Usually these suppliers are not very technically qualified, and they provide a rebar structure for them. The properties are different. The way in which the structure was calculated was different. So what's the result? If somebody who's building their house, and if there's an engineer, if they are not aware of the seriousness and they use composite rebar wrongly, and then somebody is on Instagram, they're posting away, this house collapsed. That was the problem, was the rebar. That will spread, the market will all be tarred with the same brush, and everybody loses out. So the application of the standard, a huge challenge, I think. But it needs to happen, because if not, then we will lose our business very quickly in the short term. So we need to publicize and disseminate knowledge. We need to train the people who are the applicators. They need to understand calculations. I was talking on outreach and the spread of ideas. For the larger buildings, for the large engineering firms, there's no problem. But for small builders, there is a problem. And for example, talking about buildings and smaller buildings, procure, talking about offshore construction. Some time ago, I was speaking to people and I was reading it up. The average age of a bricklayer in Brazil or a builder is 35 years old. Younger people no longer want to work in the building trade. So all of you here probably have challenges when you need somebody to help you with your own constructions. If you find someone, they're usually, white hair,